by just scratching out the hydrogens. So when I go negative charge on that carbon, what else is there that's implied that I'm not showing? A lone pair. Okay, so I don't need to do that. And I'm not. I gave you the formal charge, so you should know that there's a lone pair there. Do you see also how everything that I've taught you up to this point just keeps showing up and it just never goes away? And if you don't learn it, then when we learn new stuff, you're going to be that much more behind. We can't fall behind.
They forgot my row.
And then we would get rid of the positive charge. Now it's just a carboxylic acid. So how are we supposed to analyze this? We look at the conjugate bases and their stability. Which one's the lowest in energy? And we use the cardinal rule to help us figure that out. Because the lowest in energy conjugate base is also called the most stable. Remember, lower on the y-axis means more stable. So using the cardinal rule, what does C stand for? Charge. We're looking at 5 conjugate bases. Charge, 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 no charge. Boom, cardinal rule says that's the most stable conjugate base. If that's the most stable conjugate base because it has no charge, then that means its acid form is going to be the most acidic. Okay. So now we're done with E. So now we go A through D. We see that all of them have a charge of -1. So that's done. A stands for atom. We see a negative charge on oxygen, carbon, oxygen, carbon. Which atom can tolerate or stabilize a negative charge better? Are we using a size argument or an electronegativity argument? Electronegativity, because the relative sizes of a carbon and oxygen are the same when you go across a period. It's only when you go down a group that the atoms get bigger or smaller. Okay? So now all we have to do is compare A and C. We can ignore the others. So between A and C, which one's going to be more stable? Well, they both have the same atom. They both have resonance. So what's the next thing? Induction. And C has induction because of the 2 fluorines, whereas A does not. So which one's going to be lower in energy between A and C? C is going to be lower in energy, so that would be the next one. And then, just by process of elimination, A would have to be the next one because we were comparing those two. Now we start over with the carbons version. So when we take a look at B, we see the charge, they all have the atoms are the same. So we have resonance here. Doesn't B and D both have resonance? Yes, they do. But there's another trick here. How many resonance structures can you draw for B? See, if you have something like this, you could draw a resonance structure where you take that lone pair, go that way, and you draw a resonance structure. You can also take that lone pair and go this way. Compared to molecule D, there's only one resonance structure. So when a molecule can have more resonance structures, it's going to be more stable. Resonance induces stability. Because when electrons are localized, they're like a toddler in just one room. They just go crazy. They need their space to just mess everything up. That's just how they function. That's how kids are. And it's so funny that us adults try to tell them to stop doing that. But that's how people learn. Little kids learn. Mess things up, stick it in your mouth. That's how they experience life. Okay? And so then we would say B would be the next stable, and then D. Okay. How did we do, class? Did we do okay on that one? Okay. Now, we've already ranked. So the second question. Looking at the conjugate bases that we've just analyzed, which one is the strongest? Now, when we take it and look at the y-axis, we have E down here, the conjugate base of E, and the conjugate base of D. That's what I'm representing, okay? So clearly D is the highest in energy. So it is the least stable, or say the most unstable. How can that molecule D become stable? By reacting. So it's going to grab a proton so it can become neutral. So because it's so high in energy, if D and E can talk, E is like, I'll get to it when I get to it. D, on the other hand, is like, this sucks, life is stressful, high in energy, I need to react quickly. Because once I react with the proton, I get lower in energy. So D is the most unstable, which makes it the most reactive, making it the stronger base. Do you see how I'm always relating my analysis back to energy levels and the stability? So D, so you would draw this guy right here as the conjugate base, or the strongest base. Now, the last question said, just look at the original molecules. Look at the original molecules. I know they're acids, okay? We know they're because they're carboxylic acids. But let's just spin it a little bit. Let's assume that they're bases. If we called them bases, which one would be the strongest base? So we have to think about this. If we contrast the two, if we take this guy right here, okay, and say, what would that look like if it became a base? What do bases do? They grab protons. So if this grabbed a proton, it would look like this. Okay? If we took molecule D, like this, and treated that as a base, we would get this species right here. Now look at the stability of those two guys right there. Which one is the most likely reaction to occur? The top one or the bottom one? Well, the top one has what? 2 charges, and the bottom one only has 1 charge. So the reaction that's most likely going to occur would be the bottom one. Because why would the top one, it's already charged, it's already unstable, why would it want to react as a base to grab another proton and make it more unhappy? We're like, no thank you. But the bottom one's like, yeah, I can deal with it. Right? And then grabs it. So that would be because we're looking at the stability of these and saying which one's the most likely one to occur. We can say, hey, this guy would be the stronger base. Do you see how I'm always relating it to energy levels? Using the cardinal rules and the principles and making some judgment calls. Okay? We are out of time. If you have any questions, let's chat. You guys have a good rest of your week.